Welcome to Lesson 31. In this bonding lesson, we are going to learn how bond polarity and ionic character are related to electronegativity. By the end of this lesson, you should be able to classify bonds in terms of their polarity and in terms of their ionic character. Let's begin. Bond polarity is related to the word polar. Polar means different. A bond is polar when it has two charged ends, a negative charge and a positive charge. In order to find bond polarity, or a dipole, you'll have to find the difference of electronegativity. The greater the difference of electronegativity, the more polar a bond is. Polar bonds influence the chemical properties or reactivity of substances. So in order to calculate bond polarity, we are going to have to use reference table S. We will have to find the electronegativity between two atoms in a bond and subtract them. If there is no electronegativity difference, there will be a nonpolar bond. So let's look at a compound of hydrogen. These two identical atoms have the same electronegativity, so they have no difference. You cannot tell the difference between the atoms on the left or the atoms on the right. Again, you can see here in chlorine, this is a nonpolar bond because the left and the right are identical. All chlorines have the same electronegativity, so there is no electronegativity difference. The greater the difference of electronegativity, the more polar a bond will be. When I look up the electronegativity values of hydrogen and chlorine in hydrogen chloride, I see that hydrogen has an electronegativity of 2.2, while chlorine has an electronegativity of 3.2. The difference is 1. The greater the difference, the more polar the bond. Ionic compounds are formed between metallic atoms and nonmetallic atoms. Metals and nonmetals have very different electronegativities, so the more the difference of electronegativity, the more ionic the character is. Ionic bonds transfer electrons, and so they are actually very polarized as they end up with a positive ion and a negative ion. The easiest way to tell if a bond is ionic is if it has a metal and a nonmetal. So when we have a nonpolar bond, it only occurs between diatomic elements. Nonpolar bonds have elements that equally share electrons. They share equally because they have identical electronegativities. Each fluorine has an electronegativity of 4.0 on reference table S. The difference is 0. Place these notes on the chart under polar covalent. The contrasting elements in a polar covalent bond share electrons. They have slightly different electronegativities. The more electronegative element will pull the electrons towards it more frequently. So here in the hydrogen chloride, you can see the more electronegative chlorine on the right pulls electrons towards it more often than the less electronegative hydrogen. When there is a polar bond, it is called polar because it has a more positive end and a more negative end determined by the electronegativities of the elements. In this example, oxygen-hydrogen bond has a positive hydrogen end, as hydrogen's electronegativity of 2.2 is less than oxygen's electronegativity of 3.4. We show the partial charges with the Greek symbol delta. So again, oxygen has a partial negative charge, while hydrogen has a partial positive charge. Write these notes and the guided notes under ionic bonds. Ionic bonds are extremely polarized because they actually have two distinct charges. They have positive cations and negative anions. There is a complete transfer of electrons due to the very different electronegativities of metals and nonmetals. Nonmetals have high electronegativities and easily attract the electrons from the metals. After transferring electrons, each ion has a more stable, complete, low-energy valence electron configuration, and the total charge of the compound is now 0, also like the charge of noble gases. So in summary, you can see that nonpolar covalent bonds form when the same element bonds with itself. Since there is no difference of electronegativity, there are no ends to the molecule. In a polar covalent bond, the electrons are shared between two nonmetallic elements, but the higher the electronegativity of an element is, the more strongly it can attract those shared electrons. So in this example, you can see that chlorine attracts the negative electrons more often. And ionic bonds form between metals and nonmetals. They are very different, and that is why metals lose their electrons to the very electronegative nonmetals. They are very polarized. Due to identical differences in electronegativity, electrons are shared equally in nonpolar bonds, unequally being favored by the higher electronegative element in polar covalent bonds, and electrons are transferred in ionic bonds. So you can see that in a nonpolar bond, both sides of the bond are identical. But in a polar covalent bond, represented here with hydrogen and fluorine, both sides are not identical, and the more electronegative element, in this case fluorine, will attract the shared electrons more frequently. In an ionic bond, electrons will be transferred from the metal to the nonmetal. In a diatomic element, the total charge is 0. There are no charges present when electrons are shared equally. But in a polar covalent bond, electrons are unequally shared, so there's a partial positive charge and a partial negative charge, but the total charge of the compound still remains neutral or 0. In an ionic bond, electrons are transferred. We show the transfer of electrons by showing the charge of each individual ion, making sure that the oxidation states of all the ions adds up to 0. Okay, class, now let's work on some practice Regents questions. In this question, they ask what bond is formed between phosphorus, element number 15, and chlorine, element number 17. What we know is that phosphorus and chlorine are to the right of the bold staircase, so these are two nonmetals. Looking for a bond that will form between two nonmetals. So we know that covalent bonds are between two nonmetals. Now we have to distinguish whether or not the bond is going to be polar, meaning different. Are the two elements different? Or nonpolar, which is not different. Okay, so let's work on some homework questions. Here, we're looking for the bond type between phosphorus, element number 15, and chlorine, element number 17, because both of these fall to the right of the bold staircase. They are nonmetals. So we're looking for a bond that will form between two nonmetals. So we know that covalent bonds are between two nonmetals. Now we have to distinguish whether or not the bond is going to be polar, meaning different. Are the two elements different? Or nonpolar, which is not different. In the next question, we are looking for which element has the least or lowest ionic character. Now, when I look at my choices, all of the options are nonmetals bonded. They're all covalent. Ionic character is determined by the difference of electronegativity. So we're going to have to look up the electronegativities on reference table S. The electronegativity of chlorine is 3.2. So we are going to compare the electronegativity of 3.2 for chlorine to all the rest of the elements. Looking at element number 15, phosphorus, it has an electronegativity of 2.2. And bromine has an electronegativity of 3.0. Hydrogen, 2.2. So we're just looking up this number right here on reference table S. And sulfur is a 2.6. We're looking for the combination that has the least difference. In this question, we are looking for the bond that is most polar. Remember that polar means different. Here, we're going to use the difference of electronegativity to find which has the most difference. To find electronegativity, you're going to use reference table S. So you can see here that chlorine has the electronegativity difference, the electronegativity of 3.2. But in diatomic chlorine, each element of chlorine has an electronegativity of 3.2. In hydrogen chloride, the chlorine has an electronegativity of 3.2. Remember, the more negative element is typically written in a formula last. So I'm going to write its electronegativity first because it'll make subtraction easier. While hydrogen has an electronegativity of 2.2. So this difference is 1. Bromine has an electronegativity of 3.0, while hydrogen again has 2.2. And lastly, we have hydrogen iodide. So we're going to write the electronegativity of iodine and subtract that from the less electronegative hydrogen. Here we are looking for the most. In this question, we are asked to describe ionic bonds. We know ionic bonds are between metals and nonmetals. And we're looking at the metallic atoms to see what types of ions they form. So you can look on your periodic table of elements. On your periodic table of elements, the metals are to the left of the bold staircase. Looking at their ion charge, which is only true in a bond, we can see that metals tend to form positive ions. So that means we can get rid of the choice A and choice C. Next, we are asked to determine whether or not we are gaining or losing electrons. Remember that electrons are negative. Gaining a negative causes your charge to go down, and losing a negative causes your charge to go up. We can remember this because Leo the lion says grr. The loss of electrons is oxidation, and the gain of electrons is reduction in charge. Here, in the final question, we are asked to find a molecular compound. The word molecular means covalent, and a covalent compound forms between two nonmetals. Look up each element in each formula and figure out which formula has two nonmetals. This concludes Lesson 31 in our bonding unit. Make sure you write down any questions you have and bring them to class. See you soon.